Hi guys, good morning. The time is actually 12:17 p.m. The date is 3/14/2023, so it's actually afternoon. And I have y'all looking at EMSC, and we are going to go over the earthquakes that have occurred since 0002:08.3. So that's since midnight my time. Anyways, you guys, we will start with the 4.5 in the Molucca Sea. And I have not looked at any of these earthquakes yet, so you will be looking at them along with me. And we will see what is in the area. Now, we can see that this earthquake is occurring next to the subduction zone and the oceanic transform fault. So that is where this earthquake is occurring, and this is North Sulawesi. And as usual, you can see itty bitty little underwater seamounts. This subduction zone leads up to this subduction zone, and this is a subduction zone, and over here is a continental transform fault. We shall go on to the next earthquake. So that was a 4.5 in the Molucca Sea. The next one was a 6.3, which I covered on our last night's video right after my update. But we will go and look at the area again. It was 214 kilometers deep. Oops. And this one was occurring next to Long Island volcano, which is a complex volcano. I do not believe there were any views for this one. However, this is Wisdom Lake here. We'll move on to our next earthquake. Now, I usually only do 4.0 and above. However, on the last video I did, which I will post at the end of this video, I did an update this morning for California earthquakes as of this morning. So the next earthquake is a 4.2 in the Molucca Sea. It was 22 kilometers deep and 158 kilometers northeast of Lakit, Lakit 2, Indonesia. Population there is 8,000. Now, some of y'all may be asking why I changed my video update time, and it is because of the fact that I have a friend who does their updates on their channel during the time that I had picked. So I have changed my update time to earlier so that it does not conflict with their video update time. Okay. Here is a subduction zone, and here is the oceanic convergent boundary, and here is a continental convergent boundary. Down here is a continental transform fault. Over here is Ruang volcano, and this volcano is Karangkadang. So we can see the different volcanoes that are in the area, and this earthquake is striking in between both of them and pretty close to the subduction zone. But it's striking closer to this line of volcanoes. And this is northern Sulawesi here again. Move on to the next earthquake. which was a 4.5 offshore Chiapas, Mexico. We can see this one is offshore here, and this is the subduction zone. We'll back out and we can see that the arrow shows the convergent arrow here. And I'm going to see if I can pull up this one. This one moves at a 61 millimeters a year. Convergence data are shown by arrows describing direction and speed relative to the plate across the boundary. And this comes from minerals.si.edu/tdpmap/. And I think it's awesome to see that they show how the movement is done. And this here is the Sandwell Ridge in the green. This also right here is a Cocos Plate. Then we can see all the little volcanoes that are down in this area here. That one there is San Cristobal, Santa Cruz, Genovesa, Marchena, Penta, and so on. That one there is Galapagos Rift. That one there's a submarine volcano. And we move on to the next one, which was a 4.1 offshore Chiapas, Mexico. It was 9 kilometers deep, 104 kilometers southwest of Puerto Madera, Mexico. Population 9,500. And we get this into Google Earth here. And it looks like it's almost within the same area. Again, it's hitting by the subduction zone, but closer to the continental rift boundary. And again, this is the Cocos Plate here. Then we had a 4.2 in northern Sumatra, Indonesia. It was 10 kilometers deep, 67 kilometers east-southeast of Muloba, Indonesia. Population 35,000. This one is hitting right next to the continental rift boundary. And it's close to Karangadong volcano, which is a stratovolcano. Don't know if there's any views there we can see. There appears to be, but we'll go over here. See if we can view it. And looks beautiful, but I don't see it. Don't think that that's it. Uh, don't see anywhere for that one. Anyway, moving on to our next earthquake. We had a 4.2 in the Molucca Sea, and it was 80 kilometers deep, 78 kilometers southeast of Ternate, Indonesia, population 33,300. This one was offshore. And again, that's in that area of northern Sulawesi. That's the subduction zone, oceanic transform fault, and the continental transform fault is there. Moving on to our next one, I'm going to do this 3.6. It was in Colorado. It was 9 kilometers deep, and it was 22 kilometers west of Trinidad. So this brings on the continued earthquakes for Colorado. And you can see all the pads around here. If you look, I'm not so sure what I'm seeing in this area. You can see houses over in here. This is West Spanish Peak and Spanish Peaks Wilderness. East Spanish Peak is over here. Look at all these points. Anyway, move on to our next earthquake. Which was a 5.5 Pacific Antarctic Ridge, 10 kilometers deep, 3,035 kilometers north of Mercado Station, Antarctica. And we can see that this is hitting next to Samuel Ridge and the oceanic fault. That's the oceanic transform fault here. And very close to an unnamed volcano. This is a submarine volcano. And this is, of course, Antarctica. Moving on to the next earthquake, we had a 4.1 Madeira Islands, Portugal region, Portugal, 5 kilometers deep, 172 kilometers west-southwest of Arco da Carreta, Portugal, population 3,200. And out in the ocean, but it is near the island of Madeira. And not near any lines, but if we were, it would be the oceanic convergent boundary, the oceanic transform fault. So it is again hitting in between the volcanic areas. Our next earthquake is a 4.5 near the coast of central Peru. This being Peru, this being the continental rift boundary, and the subduction zone. We'll pull back out and see that the arrow shows that it subducts to this direction. And it subducts at 73 millimeters a year. Moving on to our next earthquake. By the way, that one was 4.5 at 42 kilometers deep. Our next earthquake is a 4.2 near east coast of Honshu, Japan, and it's 60 kilometers deep, 72 kilometers southeast of Ishimaki, Japan, population 117,000. And we can see that this plate subducts to this direction. And that's the subduction zone here. It subducts at 92 millimeters a year. So we can see our arrows show that this plate subducts in this direction. Moving on to our next one. Was a 4.6 in Turkey. And I believe that they're just going to keep having aftershocks for a long time since the fact of that big earthquake. I believe it may have actually been bigger than it showed. Our next earthquake is going to be a 4.1 offshore Atacama, Chile. It's 38 kilometers in depth, 93 kilometers west-northwest of Copiaco, Chile, population 129,000. Now we can see this is where this earthquake is struck out at sea, and this is a subduction zone, and it is subducting towards this direction. So we can see our arrow shows us subducting that way at 79 millimeters a year. And we are also right outside the Cocos Plate. So I've been seeing a lot of movement on the Cocos Plate lately, and there's been a lot of statements that if the Coco Plate is very badly disrupted, that it could cause it to shift and cause bigger earthquakes. I think that that could possibly be something to be concerned about. We move on to our next earthquake, which is an earthquake in western China, western Xinjiang. It was a 4.0, 140 kilometers deep, 247 kilometers north-northwest of Sega, China. Population 3,700. So we're over here in China, and I feel like I showed this area yesterday in video, but there's another earthquake over here. That's Tarakou, Zarinamko. If we look at this area, it is hilly. And then we have the continental convergent boundary, which is over here. Yeah, the arrows that show that the land moves that way at 48 millimeters a year. So here's your arrow showing which way it moves. And we had a 5.0 off the east coast of Kamchatka. It was 10 kilometers deep, 164 kilometers southeast of Petrovka. Wait a minute. Petropavlovsk, Kamchatsky, Russia. Population 187,000. Okay, you can see that we are right next to our subduction zone. And this one moves at 78 millimeters per year, with the arrow showing that the plate moves this way. You can also see that this is next to the line of volcanoes, which are along this area. And this is the Sea of Osh. This is the Bering Sea over here. Then we had a 4.5 in Halmahera, Indonesia. It was 40 kilometers deep and 63 kilometers north of Tebelo, Indonesia. Population 10,000. This is striking right on the continental convergent boundary and the continental rift boundary. They intersect each other right here. This is Bao Island. Then we have a 4.0, Mentawai region, Indonesia. 12 kilometers deep, 110 kilometers west-southwest of Sungai, Indonesia. Population 95,900. This one is out to sea here. But if we look over this way, we have our subduction zone. We'll see which way our arrows go here. They run this way. This here is the oceanic convergent boundary. This rift moves at 70 millimeters per year, or this plate. We can see this is the Cocos Islands here. So when we pull back, I just saw it. Cocos Keeling Islands are right here. Christmas Island is over here. Not to be confused with the Cocos Plate, which is over by the United States and North America, which is right here. They have Cocos Islands down here as well. Isla de Coco. Moving on to the next one. We had a 4.2 south of the Kermadec Islands. Which is sitting outside of the oceanic spreading rift. And I'm going to check on GeoNet to see if that one shows. I believe this one may be at 4.0. That's a 14th. That's the 13th. It's the 14th. Let's see here. 12:34:28. Four hours. Shows 4.4. 4.4. It shows here is a 4.4, 539 kilometers deep. It was unnoticeable. Shows Wednesday, March 15th, even though my date here is the 14th, because we are a day behind. The history of this quake was 4.4, 4.1. So the biggest was 4.4. And EMSC has it as 4.2. Okay. So this is the area on EMSC for it, next to the oceanic spreading rift. And the subduction zone moves at 88 millimeters per year. So this is the plate. And this is the plate boundary here. Subduction zone. Where am I going? Okay. Oops, I went back to the wrong page. Okay. Then we have a 4.5 in Mindanao, Philippines. It was 169 kilometers deep, 126 kilometers southeast of Pandangtan, Chile. Philippines, sorry. Population 2,100. I think I'm reading the top of my page while I'm reading my update because there was just a bigger quake. This earthquake is striking near the subduction zone. And this area subducts this way. There's also an itty bitty little island right there. Mangas. And it looks like there might actually be some houses on it. Then there was a 4.2 off the coast of Mexico, Oaxaca, Mexico. It was 16 kilometers deep, 129 kilometers southeast of Salina Cruz, Mexico. Population there is 76,500. And we can see that this is our subduction zone here. This is also off the Cocos Plate as well, which is subducting to this direction. And it's subducting at 61 millimeters per year. And note the last earthquake was down in this area, so we now have quite a few that are hitting along here. Our next earthquake is a 4.8 in Turkey, and Turkey, as I said, is going to continue to swarm. Our next earthquake is a 5.6 central Mediterranean Sea, 5 kilometers deep. If you look, this looks like there may be an underwater seamount here, and it's also hitting next to the subduction zone. And the subduction zone goes this way at 9 millimeters a year. This is the Mediterranean Sea here. Okay, so our quick news update, real quick. The EPA is moving to limit toxic forever chemicals in drinking water. The Environmental Protection Agency on Tuesday proposed limiting the amount of harmful forever chemicals in drinking water to the lowest level that tests can detect, a long-awaited protection the agency said will save thousands of lives and prevent serious illness, including cancer. The plan marks the first time the EPA has proposed regulating a toxic group of compounds that are widespread, dangerous, and expensive to remove from water. PFAS, or per and polyfluorinated substances, don't degrade in the environment and are linked to a broad range of health issues, including low birth weight babies and kidney cancer. The agency says drinking water is a significant source of PFAS exposure for people. The science is clear that long-term exposure to PFAS is linked to significant health risks, Radhika Fox, assistant EPA administrator for water, said in an interview. Fox called the federal proposal a transformational change for improving the safety of drinking water in the United States. The agency estimates the rule could reduce PFAS exposure for nearly 100 million Americans, decreasing rates of cancer, heart attack, and birth complications. The chemicals had been used since the 1940s in consumer products and industry, including in nonstick pans, food packaging, and firefighter foam. Their use is now mostly phased out in the United States, but some still remain. The proposal would set strict limits in 4 parts per trillion, the lowest level that can be reliably measured for 2 common types of PFAS compounds called PFOA and PFOS. In addition, the EPA wants to regulate the combined amount of 4 other types of PFAS. Water providers will have to monitor for PFAS. The public will have a chance to comment, and an agency can make changes before issuing a final rule, which is expected by the end of the year. Water providers will have time to adjust. The Association of State Drinking Water Administrators said the proposal is a step in the right direction, but compliance will be challenging. Despite available federal money, significant rate increases will be required for most of the systems that must remove PFAS, the group said Tuesday. Environmental and public health advocates have called for federal regulations of PFAS chemicals for years. Over the last decade, the EPA has repeatedly strengthened its protective voluntary health thresholds for the chemicals, but has not imposed mandatory limits on water providers. Public concern has increased in recent years as tests reveal PFAS chemicals in growing list of communities that are often near manufacturing plants or Air Force bases. Until now, only a handful of states have issued PFAS regulations and none has set strict limits as to what the EPA is proposing, but regulating PFOA and PFOS at a minimum amounts that tests can detect. The EPA is proposing the tightest possible standards that are technically feasible, experts said. This is really a historic moment, said Melanie Benesh, Vice President of Government Affairs at the Environmental Working Group. There are many communities that have had PFAS in their water for decades who have been waiting for a long time for this announcement to come out. The agency said its proposal will protect everyone, including vulnerable communities, and reduce illness on a massive scale. The EPA wants water providers to do testing, notify the public when PFAS are found, and remove the compounds when levels are too high. Utilities that have high levels of contaminant are generally given time to fix the problems, but they could face fines or loss of federal grants if problems persist. The proposal would also regulate other types of PFAS like Gen X chemicals, which manufacturers used as substitute when PFOA and PFOS were phased out of the consumer products. The proposal would regulate the cumulative health threat of those compounds and mandate treatment if the threat is too high. The EPA recently made $2 billion available to states to get rid of contaminants such as PFAS and will release billions more in coming years. The agency also is providing technical support to smaller communities that will soon be forced to install treatment systems, and there's funding in the 2021 infrastructure law for water system upgrades. I'm glad that they're making these changes because we've had a problem with forever chemicals here in North Carolina as well. The city of Goma in the east of the Democratic Republic of Congo on Monday was on high alert after a local volcano shows signs of erupting. Local authorities in North Kivu, including Goma Volcanological Observatory (OVG), said that current seismic data indicates a movement of magma at shallow depths towards the central crater of Nyamulagira, citing the name of the local mountain, which is here. The OVG had already announced earlier the location of what it called hybrid earthquakes in the Nyamulagira, and said it feared a possible magmatic intrusion. We recommend to the people of Goma to remain calm and to go about their business freely, OVG said. However, it warned pilots to fly with caution while in the area, especially taking into account the wind direction when flying over the Virunga region. OVG Director General Adalbert Mehendo said the volcanic products such as ash and slag from the volcano can fall on inhabited areas in the crater. In 2021, the Nyiragongo volcano erupted, forcing the people Goma to flee the Rubavu region of Rwanda and other cities in the DRC. An earthquake affected both Rwanda and the DRC after the volcano erupted. In 1977 and 2002, North Kivu was also shaken by volcanic eruption. So this is what this volcano looks like. We'll see if we have any views here. And we do not. The other name for it is Nyamuragira. And let's see if we can do a tilt. So we can see that this is what this this volcano looks like, and it is also a shield volcano. So scientists are worrying about snow and rain in California and the effect of rain on snow in California mountains, and it's worrying scientists. Another round of powerful atmospheric rivers is hitting California following storms in January and February of 2023 that dumped record amounts of snow. This time the storms are warmer and they are triggering flood warnings as they bring rain higher into the mountains on top of snowpack. What happens when rain falls on snowpack? For much of the United States, storms with heavy rainfall can coincide with seasonal snow cover. When that happens, the resulting runoff of water can be much greater than what is produced from rain or snowmelt alone. The combination has resulted in some of the nation's most destructive and costly floods, including the 1996 Midwest flood and 2017 flood that damaged California's Oroville Dam. Contrary to common belief, rainfall itself has limited energy to melt snow. Rather, it is the warm temperatures, strong winds, and high humidity that can transport substantial energy in the form of latent and sensible energy that predominantly drives snowmelt during rain-on snow events. Snowpack has air spaces that water can move through. As the rain falls, the water can travel relatively rapidly through the snowpack's layers to reach the underlying soil. How streams respond to that runoff depends on how much water is already flowing and how saturated the soil is. When the soil isn't yet saturated, it can dampen or delay a flood response by soaking up rain and melting snow. But when the ground is saturated, snowmelt combined with rain can lead to a fast and devastating flooding. One of the challenges for dealing with these rain on snow events is that the flood risk is hard to forecast. To predict whether a flood will occur requires knowledge of weather and hydrological conditions. It requires knowing the soil moisture and snowpack conditions before the storm, and elevation at which rain transitions to snow, the rainfall rate, the wind speed, air temperature and humidity, and the estimates of how those factors contribute to snowmelt. Additionally, each factor varies in time during a storm and varies in complex ways, especially across a mountainous landscape. This is why rain on snow floods are characterized as compound extreme events. Despite the extensive damage they can cause, it may be surprising how little is known about how they vary in time, spatial extent, and intensity. In California mountains right now, it's the middle elevations that people need to pay attention to. The lower elevations have primarily seen rainfall rather than snow, so there is less snowpack to melt. And in the highest elevations, colder temperatures promote the continued accumulation of deep snowpack, and rainfall is less likely. In the middle transition zone, where either substantial rainfall or snowfall can occur, rain on snow events are most common, causing both melting and risk of roof collapse, sorry. If all storms are created equal, there would be well-defined rain zones and snow zones, and the rain on snow flood risk would be low. But that isn't what happens. Instead, not only does the snow zone evaluation vary during an event, but it is also varying substantially from one storm to the next. The most destructive rain on snow event occurs when rivers are already running high and soils are saturated, which can occur in response to a series of warm atmospheric rivers interacting with deep snowpack, like California's mountains have right now. The order in which these storms occur or the storm sequencing is especially important for assessing flood risk because these events are in part caused by rapid shifts between cold periods of snow accumulation following a warm rainfall event. Even less is known about how rain on snow flood risk may respond as the planet warms. In a warmer climate, there will be less risk of rain falling on snow in the lower of the elevations as the snowpack declines, particularly in warmer regions such as the Pacific Northwest. But at higher elevations, more frequent rain on snow events are expected. While warmer temperatures are expected to increase rainfall intensity, research shows that's not the most important driver to this risk. Much of the expected increase in rain on snow flood risk is a result of the rain-snow transition zone expanding higher in elevation to include alpine areas that historically receive predominantly snowfall. Flood control and reservoir management systems in these mountain regions will have to consider these future changes in rain on snow events, in addition to changes in rainfall intensity and storm sequencing, to fully understand and prepare for the local flood risk as the planet warms. 1 second. So will projected increases in precipitation extremes and winter rainfall increase rain on snow occurrence and associated flood risk, or will snow less snow cover and larger soil moisture deficits reduce rain on snow flood risk in a warmer climate. In a future climate, the response on snow on rain flood risk is expected to change in complex and often contradictory ways. The projected changes are likely to vary by region, season, climate model, emission scenario, and future time horizon. It's costly risk that requires much research. And this article is on the conversation, so you can look it up. Oh, South Lake Tahoe. City officials in South Lake Tahoe are urging residents to stop harassing snowplowers. The city, like pretty much all Sierra Nevada recently, has been coated with heavy blankets of snow. Snowplowers have been operating along Sierra Tract, State Line, Bijou, and Tahoe Island to try and keep vital roadways clear. However, the city says frustrated residents have allegedly been harassing drivers and making their job even more difficult. Some drivers have even reported having objects thrown at their equipment, the city says. We know this has been a tough winter for everyone, but it does not warrant this behavior. Just be kind, the city said in a statement on Monday. While the city says they understand that many residents are upset about having snow berms, officials say the berms are inevitable due to the limited space on the roads along with the snow conditions. With the snow being wet and heavy, the city warns that the berms will be even more difficult to clear. Please be nice to people that are there to help you. Okay, now we're going to go over Oregon Live earthquake map and see if there's been anything new within today. And today is the 14th, so we're looking for 14th stuff. That's the 13th, 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 11th, 13th, 12th. Not seeing anything out this way yet. Still looking. You can see we got a nice little swarm going on over here by Nevada. 2.3, a 2.8. Let's pull up Nevada real quick. See what we got going on with Nevada today. We have a 2.0, a 2.3, 2.7, 2.0, and a 2.3 in Nevada. Let me close some stuff real quick. So we have quite a few, to include small ones that are going on in Nevada. We have a 1.6 over here. And that was yesterday, 1.3. That's a 1.3. We have a 2.2, Georgetown, Idaho. We still have quite a swarm going on over here. This is Montana area. We had a 1.4, and this is by the Yellowstone in Montana. Have quite a few earthquakes for Oklahoma, but I'm not sure if we have any for today yet. Let's see. Yep, we had one. It was a 2.0 in Oklahoma. It was 7 kilometers deep. So it would be nice if they only made the red ones, the ones that happened today. But I'm not seeing it. Anyway, moving on. I'm looking for something on the East Coast. And I'm not seeing anything there. It looks like the East Coast has been nice and quiet. So there should be more activity coming along the East Coast here soon. Anyways, you guys, thanks for watching the video. Please remember to like, subscribe, share, and much love.